All right, so this is section 2.5, which goes over two quantitative variables. Now, the main thing we're going to be looking at are scatter plots. And the purpose of scatter plots are to help us see whether there's a relationship between two quantitative variables. So let's get started. We've got scatter plots, scatter. All right. Now, before we start filling out the blanks, I just want to look at an example here. So in this one, they've got minutes versus points scored. So the idea here is that if you play more minutes of basketball, it's going to increase your chances of being able to score more points. Now, whenever we look at a scatter plot, whenever you look at the horizontal axis, that's usually what we're going to call our x variable. Then the output, the thing that's happening because someone is playing more minutes, in this case, the points scored, we're going to label that our Y value. Now, in our class, what we're specifically looking for is a type of relationship that's known as a linear relationship. Now, think about it this way. If somebody doesn't play, well then of course they're not going to score any any points. But as they do, what typically tends to happen, and let's just start from 0, 0, and do your best to try to draw a line through all of these dots where basically what we're trying to do is like half the dots above, half the dots below. Again, whenever you do this for yourself, it doesn't have to be perfect, but we can see what makes sort of like the shape of a line kind of cutting through all these dots. And so that is what today is all about, is trying to see if when you compare something that is our X value and our Y value, whether we can see that there's a linear pattern or a linear trend. Now, there's going to be two main types of scatter plots that we're going to be looking at. One of them, well, let's start with this guy, is whenever there's an upward trend, which is as you're going from left to right, you notice that things are on the increasing. And this specific one is going to be known as a, whenever we see that kind of like an upward hill, we're going to call that a positive association. So we've got positive associations. Again, in this class, we're thinking like linearly, like straight line. But then we're also going to see some where sometimes it's going downhill, where there's a negative association. Now, those are our two main ones that we're interested in. There are some that have no. I'll show you one. I'll show you a graph where there's like no linear relationship, kind of a boring graph. There's nothing interesting about it. But the other one that we have on this first page is a negative association. That's because when we look at this graph, we can see it going downhill. There is a downward trend. We'll call that a negative association. Now, you don't have to say negative linear association, but just negative associations enough. But yeah, we do see as we look at this graph that you kind of start up at the top, and I'm not sure that I'm going to do a perfect job, but let's just try it. Let's just kind of do a line through these dots, something like that. And I'm sure I could have done a better job, but you try it. The idea is that you're kind of in the top left corner and then you kind of work your way down to the bottom right corner. And what's happening on this one is X is the weight of a vehicle. And as a vehicle gets heavier and heavier, what tends to happen, the Y value being the miles per gallon, is not so good. Like your smaller cars are going to get more miles per gallon. Your heavier cars are going to get, not so much. So those are the two main types of associations we're going to be looking at whenever we're looking at these scatter plots. Here's also a version of a situation where there's no association. And on this one, it's what they did is they took, again, still with vehicles, X was how much a like the tank could hold in terms of like gallons, and then Y was whatever page number it was on some like vehicle book, And you can see here, yeah, there's no like upward trend, there's no downward. It's just like a big mess of scattered dots. And so if anyone was to ask you like how would you describe this, you would say, well, there's no linear association. Now, that's not to say that this graph isn't useful. The purpose of it is, or what we could do with this is say, each one of these dots is giving us an ordered pair. So, for example, there was one of these vehicles that could hold 28 gallons of gas. And we could then use the graph to find what page number it was on. And if you look down here, there's maybe this is the one that they're talking about. That seems to be kind of where 28 is. Maybe that dot there. Then if you go off to the side, it looks like it's maybe on page 175, something like that. And we know in this class that anytime we're, estimating, it's okay if you and I are a little bit off on our estimates, as long as we're pretty close. But yeah, page 175. Now, the other really big thing besides just physically looking at these scatter plots to see if there's anything interesting between the two variables is if there is, then we want a way to be able to measure that relationship. And this is how we do it. It's known as correlation. So correlation is going to be a number that does two things. It tells us how strong the relationship and then the direction. Direction being whether it's, negative or whether it's positive, like whether things are increasing as you go from left to right or decreasing. And here's the interesting about correlation. It's going to be a number between -1 and 1. Now, remember, we've got some stuff that's negative, positive, but then in the middle, we've got 0. And what we're going to do with 0 is to be the indication that if there's nothing interesting between two quantitative variables, then it's going to have a correlation of 0. That there's nothing interesting about it. Now, I've got one more blank here that I'm going to put for our notes, which is the word closer. And so whenever we look at a scatter plot, we will physically be able to see either a line or maybe not a line. And when we do see a line, there's going to be a way to just even with our eyes just be able to think, oh, hey, there's an obvious. I think there's an obvious appearance of there being a relationship between these two quantitative things. Now, the little number line that you see here is this whole idea of whether things are more interesting or less interesting, and kind of the one about the fuel capacity and the page number. There was nothing interesting about that. There was no relationship. And so anytime that happens with two other variables that have no association and you look at the scatter plot, it's going to look like this, just a random sort of like mess of dots where you can't see a line going up or down. That's going to be your, not great graphs. Now, I'm going to start with the positive side. The positive side, and I'm not going to do 3 different pictures, just at least 2, where as X is increasing, Y is also increasing. So you've got like an upward trend. But what do we mean that we'll be able to see when things are on the stronger side? It'll be that the dots will be closer to the line. You'll be able to see a upward trend, and maybe the dots will be something like this, like pretty close. I mean, they might have some little bit of scatteredness to them, but I'm going to kind of exaggerate it here a little bit where, yeah, all the dots are kind of hanging pretty close to the line. And then that would be considered something that's more on the strong side. Something maybe that's falling into like the weaker or maybe even like moderate, like you'll still be able to see a line, but they're going to be more loose, like a little bit more spread out from each other, but you'll still be able to say, hey, I can see a line kind of going uphill. Just it's just not as apparent as on your stronger stuff. Now, don't get fooled, right? Negatives don't necessarily mean all the time that they're going to be a weak or no association. You actually do have some negative correlations that are going to be strong. So again, I'll do 2 over here. Negative just means that as one variable is increasing, the others, as one's increasing, the other's decreasing. And you still have some strong stuff, right? I mean, you have negative zero point 0.8. Again, I'm going to put negative 1 here as sort of like as far as it'll ever go. I should have done that over here as well. Like 1 is the farthest you ever go on the positive side. But if you're getting to something like negative zero point 0.8 or negative zero point 0.9, that's going to be a downward trend. And again, the dots will be pretty close to the line, like a bit more packed together. I mean, you might have some that are a little bit kind of floating off away there, but and we'll look at some examples on the next page. But when you get to your moderate, like weak stuff, that's where you'll be able to notice still the line going downhill, but things a bit more like spread out. But you'll say, hey, there's still a line there, it's just a bit more loose. And again, I'm going to try to exaggerate this a little bit more. Yeah, you have your lines, your dots like pretty close to the line. But let's try this. Let's try this on the next page. And like, will there be some notations that sometimes pop up? Yeah. If you've done a correlation and it's based on just the sample, like not the entire population, we use R for that. And if you do the correlation for the entire population, it's known as rho. Looks kind of like an italicized P. All right, so let's go and let's just try this. All right, we've got 4 graphs here, and even as you look at a 4 of these, again, keeping in mind that things that are stronger whenever the dots are a lot closer to the line, and imagine this being sort of graph A, graph B, and graph C and graph D. Like, which one would you say, even before I spoil it, probably is the one that's going to be the strongest of all the relationships out there? Where you can like obviously see like, okay, yeah, there's a line there, and and that's going to be D. Yeah, D when you come here, I mean, it's pretty obvious. Like, yeah, there's a line here that we could kind of just cut straight through here. And then B right above it, you could do the same thing. I'm just putting a line through it. So both of these would be as X increases, the Y value also increases, or there's an upward trend, which means those are going to be belonging to both of these. All right, you got your 9, zero point 0.9 and 0.99, and keep in mind what these mean is, that's going to be your really strong stuff like 0 0.9, 0.99. But one of them is deserves to be stronger than the other, so that would be D. It deserves to be the 0.99, and so we use that one. And the 0.91 is still strong, right? This would be strong. This guy here is stronger, and then they would both be positive. Now that leaves us with 3 more to use. And then look at the one that's here in the middle. That's like really, really close to 0. So this would be one that's no association. And then the idea here is like, do we need that one? Well, I mean, you got both of these here, and we already done the positive stuff. And yeah, we could sort of like imagine a line going through both of those. So let's go ahead and try to do our best to do a line cutting through here as well as through here. And so because we were able to visualize the appearance of a line going downhill through both of these, that means we're not going to need this one. Right? That would be 0.08 would be like it just looks like a big mess of dots, and there's just no way to imagine any sort of line cutting through them. But for these, we can see a downward trend. So now these are our 2 that we are going to use. But in terms of like who deserves which one, think about like negative zero point 0.8. That's a strong one. And then you've got negative 0.39. that would be like maybe like right about here, maybe. And so that would be kind of a weaker as opposed to the negative zero point 0.8. And then just looking at these two, only one of them deserves to be probably more the weaker one. The other one maybe deserves to be the stronger one. And so we would go with the negative 3.9 as your, we'll just label it here, weak, negative, and then this one here would be the negative. And that's the way you want to do this when you get to the homework. It's sort of like a process of elimination. This would be strong, negative. Yeah, and again, don't let it fool you. Whenever you think of like negative, I know that sometimes in some students think like, okay, that's all your negative stuff's all going to be weak. No, you have negative stuff that's also strong as well. Right? It just means that there's going to be more of an appearance of the linear trend. All right, let's try. You'll see some of that in the homework. It's like a matching game, interpreting associations. All right, so this is now getting into like the everyday, um, kind of like what you see on a daily basis. What would you assume when it comes? And we're going to do these right now in just a second here, but whenever you're asked on the homework or quiz or test to interpret an association, let's start first with whenever it's a positive linear association. What's going to happen here is you're going to end up using the words increase, increase. So as one of the values is increasing, the second thing is also going to increase as well. When we're discussing a negative linear association, as one increases, and notice how both of these are both saying that x is increasing. But for the negative, the second variable will decrease. Right. So again, kind of keep it simple here. Whenever it's positive, it's increase, increase, and whenever it's negative, it's increase, decrease. Now, what I want you to do is I want you to look at A, B, C here. These are, and just use your everyday. What would you assume? What would you typically like imagine yourself seeing on just a regular basis? Um, Starting off with number of years of education. So as number of years of education increase, as you go to school more and more and more, what do you imagine will happen to somebody's annual salary? And yeah, it most likely going to increase. So for that reason, we would say that this is probably we had to predict going to be have it possess a positive association. Now, for the interpretation, this is in the homework where you would write like a sentence describing the first, the second thing happening. Be as years of education. And again, I want you to use the combo of increase, increase as years of education increase, annual salary, annual salary tends to increase. And the reason why I use the word tends to increase is, it maybe be just more of an observational thing. And then I want you to try B and C. Again, you can pause the recording and try this on your own and then and not let me spoil it for you. But again, it's like, what do you expect to happen? Increase, 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 decrease, or maybe nothing to happen? All right, so here it goes, right? It's that, the context matters. So if we're thinking about adults here, yeah, usually as you get older, your flexibility is not what it used to be. So this would probably most likely and unfortunately be a negative association. And as our interpretation, we would say as age increases, flexibility tends to decrease. But again, notice the combination of the words. You got the increase, decrease. Then if you thought about this one a little bit, yeah, probably not, right? As someone gets taller and taller and taller, do we notice their exam scores going up? No, there's probably not a relationship with just because you're taller that you're going to do better on exam scores. So this one again, you would just put that there's no association. That's not something that we would expect to commonly see. So again, the main thing that the lecture is trying to do is give you sort of a variety of like problem types that are going to show up, and as you do each of those, the this whole idea of like correlation, associations, starts to grow on you. Now, I've got an example here that's sort of a hey, let's put it all together, right? What have we been talking about today? It's the scatter plots correlation. Is there an association between this variable and that variable? In this case, or in this study, what it is they're comparing rebounds to free throw percentage. Again, if you're not a big, basketball fan, but, maybe you remember from our days of, PE, being in school and in the gym. Yeah, basketball, whenever a shot, ricochets off the goal because it's a miss, you want to try to get the ball for your team. That's a rebound, and usually it's the taller players who can kind of help with getting the ball for your team. And then you've got your free throw percent, which is usually whenever you get fouled, you either get to go shoot one, two, three shots, and you know accuracy matters. Some players that are really really good can maybe get like 90%, 80% of their shots in there. Those that are not so good, 20%, 30%, 40%. And so that's what we have here. And the way they're going to kind of start you off with this problem is to cut it into sections. Right? Like notice it's the same. Those in the top left, those in the bottom right. What can we say generally, in general, about them? So here's what I would do. Just go and slice it into four corners. Now, they're not saying to tell them specifically what's happening to players over here in the top left corner, but more generally. Now, whenever I introduce this to students, usually what I'll say is, well, let's just think about big picture what's happening here. When you look at players who are on the left side of the graph, are they the ones that are usually better or worse at rebounds as opposed to them on the right side? And usually what students will say is, well, everybody in the left only has about 200, 300 rebounds. The guys on the right have like 800, 900, 1,000. So those on the left, not so good at rebounds. But if you think about like the top, the upper part, these are the guys that are really good at their free throws. You got like 80%, 90%, and the guys at the bottom, no, 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 not so good. So now we put that together and say, well, those are in the top left corner, not so great at rebounds, but really, really good at their free throws. And so what we're going to do is we're going to use words like low and high. But keeping in mind, what's the low belong to? Those in the top left would be low rebounds, but high free throw percentage. And then we'll flip the script whenever we do those on the bottom right. These are players who have, let's say, like high low. And now keep in mind what's high. The rebounds are high. High number of rebounds, but low free throw percent. And this is exactly the way that I want you to do on the homework as well. Is just use low, high, small, long, short, big, and not be really long-winded, like bullet point answers for the four corners, right? Now, I believe the reason why the authors kind of set us up with starting from this corner to this corner is that if we had to decide whether this graph possesses more of a positive or a negative association, and you had to pick one of them, and maybe your first name was like, oh, that's just a mess. There's no association. No, there is something here, and it would be like this, that as you go from top to bottom corner, it seems to be going downhill, which would lead us to voting for like there's a negative association, right? Probably not a strong one. And then if we had to put like the whole overall story together, is that as the number of rebounds increases, the free throw percentage tends to go down or decrease. We would say as for the interpretation, which is what we were doing on the last page, is as rebounds increase, free throw tends to decrease. Again, use that increase decrease combo. Now, there's the graph up at the top, and you can see that they're giving us some choices here. And I want you to, again, pause the video, take a few moments to decide like which of those correlations makes the most sense. Now, it doesn't deserve anything strong, but it also doesn't deserve zero. And because of it being negative or going downhill, we don't need any of the positives. Hopefully you've taken some time to think about it, maybe pause the video, but here he comes. We don't need any of those because it's not going uphill, and we do see some sort of a line. It definitely doesn't deserve to be called a strong correlation. So if anything, maybe like a weaker negative correlation makes sense. Weak, negative. Now, moderate would be if you got to like maybe negative 0.5. All right. And then last couple things here is that if there was someone, and there is, you can go find them. There was someone who had the highest free throw percentage. They're at the very, very top. Go find them, and then straight down below, do an estimate of what their number of rebounds might have been. Yeah, you can see whoever that sharpshooter is right there, about 94%. And then if you go straight down, I would just go maybe about 300, probably a little bit off. But again, with estimates, as long as we're pretty close, it would be number of rebounds. And then another short little quick thing here. There's someone who's an outlier to the right. Yeah, that's someone who's actually really good at both things, really good at free throw percentage, really good at rebounds. And again, all you would do is just look off to the side, maybe like 84%, 80, 85, and then straight down below, 1150 for the rebounds. But again, it's just going to be rough little estimates. So even if someone were to say like, maybe 1100 rebounds and like 85% for their free throws, that'd be good enough, close enough. All right. So not much more. We're almost done here. And really all I want to do is just sort of a quick little kind of like takeaway, or also like a recall. Um, about observational studies. And actually, we'll do example 8 here, and then we'll finish off with the stat key example. This is pretty quick. Is that just be careful whenever you're looking at something that's observational, scatter plots. Even if you do happen to get a pretty nice like value for correlation, again, this here would be something like a positive, almost strong. I mean, we'll even just put it as moderate, like a pretty good correlation where there seems to be a relationship between whatever these two things are that are being compared. And these two things that are being compared are the amount of TVs that people have in countries and their life expectancy. But here's the crazy thing: if you were to interpret this, it would be, as people buy more TVs or possess more TVs, their life expectancy comes up. But of course, it'd be absurd to say, "Well, hey, you should buy more TVs, and it'll your cause you to live longer." No, you can't do that. You can't use that sort of language because a lot of these scatter plots. Watch, it's right here. It was just an observational study. So if you ever see one of these scatter plots and it was just an observational study, you cannot, even if it's got like a 0.99 correlation, um, they shouldn't be used to do cause and effect, right? You would say, well, hey, there seems to be something interesting happening there, but you can't do cause and effect because remember, there's likely like confounding variables. All righty, and then let's do this last. There'll be an opportunity in this homework to do, a stat key exercise. And so right here, we're going to do something pretty straightforward. We're going to find the correlation for this data set about Hollywood movies, uh, fourth edition, whether audience score is related to the budget. So in other words, like if someone spends more money on a to produce a movie, will that correspond to um, people liking it more? So let's go here. I'm gonna switch over to my stat key and open up a little tab here and go into stat key. And then when we're here, we're going to go to the Hollywood movies. Let's go right here. Two quantitative variables. And then on the drop down, you're going to scroll down. And thankfully, they have it in alphabetical order. There's Hollywood movies. And then be careful, we are doing fourth edition. And then also, we want the one that says audience score versus budget. So I'm going to click right on here. Boop. And when you get here, you can see what looks kind of like just a real big mess of dots. And then they're asking us, to vote. Would this be positive, negative, no association, strong, weak, moderate? And again, just kind of give you a moment to kind of think about that. And also while you're thinking about that, do a just also glance over at the numbers over here. This will also kind of give it away, in terms of whether it's deserves to be given a chance that it's maybe a week. Um, yes, audience scores versus budget. I'm actually also doing this on my big computers. But right now I got it on my iPad. I'm also doing it on my. Yeah, but seeing the 0.224, that's actually not terrible. That's like a weak. Yeah, 0.224 would be at least maybe a weak correlation. And you can also click on the regression line. You can see that there is an upward trend. So again, nothing too crazy. We'll go with maybe like a weak correlation. Yeah, I'm going to go and kind of flip back and forth here a little bit. Yeah, it says use Stacky to create the scatter plot. Boom, we've done that. It says describe the direction and the strength of the association. We would go with, I'd say it's okay to go with a weak positive. Yeah, and if you're thinking like really like weak, yeah, remember when we think about the little number line that I read earlier, like a 0.2 would be about there. I'd say it's still pretty close to being deserved to at least get labeled as a weak. Um, when it says use Stacky to find the correlation, it's a formula. It's a very like ugly formula. I mean, if you want to have nightmares, go ahead and look up the formula for calculating correlation. But we're just going to get it straight from Stacky. It's that point 224. And then it says for the data value with the lowest audience rating, what's the budget and the rating. So you're like, wait, where'd you get the 224? Yeah, that's the correlation that's right there. But then I want you to just click on that dot that's at the very bottom. Yeah, and if you do that, here I'm doing it also on my big screen computer. Yeah, it's got 523. Yeah, five. Yeah, if you click on the very bottom, I can't do it with my iPad. I don't have a mouse or anything. But yeah, if you click on the bottom dot, you'll see that it comes out to be 5, 23. So five would be the budget in terms of millions, and then the 23 would be the rating that the movie got. I'm gonna write that before I get it. 5, 23 be 5 million would be the budget, and 23 would be the rating, like the audience rating. Yeah, that was the movie that got the lowest rating, and again, they only paid 5 million as opposed to some movies who did like 250, 300 million. But all right, well, that is it. Okay, correlation. Now next time what we'll do is we'll get into 2.6 regression line. But again, if any questions come up, let me know. But I'm going to go ahead and end the recording. Have a good one.